Which of the following best explains how carbon tetrabromide has a higher boiling point than water? Carbon tetrabromide is carbon surrounded by 4 bromines. The shape of this is 4, 4, 0, and since it is symmetric with a 0 at the end of the Vesper number, it is non-polar. Then we have water. Four, 2, 2. Therefore, it is polar. And because you have hydrogen bonded to oxygen, can have hydrogen bonding. In fact, we know that water its properties are what they are because it exhibits hydrogen bonding. Yet, in this case, carbon tetrabromide has a higher boiling point than water. Obviously, this cannot be because of dipole-dipole forces, since carbon tetrabromide has no dipole-dipole forces because it's nonpolar. So what else could be causing the difference? What other forces are available? London dispersion forces. So let's check the polarizability. Bromine has a mass of 80. There are 4 of them, so that's 320, plus the 6 in carbon. Carbon tetrabromide has a total of 326 electrons. As opposed to water, oxygen has 8, hydrogen each has 1, it has 10 electrons. Therefore, the carbon tetrabromide must be much, much more polarizable than the water molecule, and the London dispersion forces are significantly strong that carbon tetrabromide has a higher boiling point. Therefore, in looking at our answers, CBr4 is more polar. We know that's wrong because CBr4 is nonpolar. CBr4 can form chlorine bonds. There's no such thing as chlorine bonds, and there's no chlorine in carbon tetrabromide. CBr4 has greater London dispersion forces due to the larger electronegativity differences. It does have larger LDFs, but not because of electronegativity differences. It has greater LDFs due to the greater polarizability of the molecule. The answer is D.